Welcome again. This is a continuation of what I had begun discussing, and I just want to give a good number of metals and the colors of the flames that can get recorded in as far as this part is concerned. And some of these metals that I'm going to center my discussion so much on are actually the group 1 elements and the group 2 elements, also referred to as alkali metals and alkaline earth metals respectively. So if I have to look at this part, I'm going to actually discuss these metals and their colors in as far as the flames that can get seen are concerned. Let me give a practical example. If I have sodium, I told you this is a metal, and this metal is actually a group 1 element, that is 2 to 8 to 1. You see, it has actually the ability to react by losing one electron. In this case, it has what we call a positive sign on top of it. I've told you that a flame test is used to actually determine or detect the presence or availability of a particular element or a metal ion. So a particular element or a metal ion. An ion is a charged particle present in a compound by the coloration of what it gives to a flame. So that means if it is sodium, I expect to see a yellow color. If I have something else like potassium, it is a group 1 element, I expect to see a lilac or a purple flame color. If it is, let me say, calcium, is a group 2 element, I can have calcium group 2 element. I expect to see an orange, red, or preferably you can say brick red color. If I go to something else like magnesium, this is a group 2 element. This is also group 2 element or an alkaline earth metal member. And in this case, I'm supposed to have what we call a bright blinding flame. People can actually call it a bright blinding flame or a bright glaring flame. These are two phrases that actually communicate the same information. If I have, let me say, something else like, let me say, caesium. Caesium is a group 1 element. Of course, I have to get capital C small s with a positive sign on top of it. This will preferably give me what you call a blue-violet color. If I have something else like rubidium, I may actually be able to have capital R small b as the chemical formula, and the color can be red, violet. Good. Red, violet. I may further have something else like barium, which is a group 2 element. So I may actually have a positive sign on top of this, a group 1 element. So barium is a group 2 element, capital B small n, with the 2 positive. If this one gets burned, I expect to see a green color as far as its flame is concerned. And if I have to get something else, I can talk about copper. And when I talk about copper, I can have copper 2. As well, copper can be able to have an oxidation state of 1. So you can have copper 2 or copper 1. So with copper 2, we can have a preferably green color, and of course copper 1 can have a preferably blue-green color. Great. And in this case, as I will always get something like copper 1 oxide, copper 2 oxide, so please take note of that. Copper 1 sulfide, copper 2 sulfide. So if I go to another metal like iron 3, of course, which is what you call a brown appearance, just in case ammonia solution or sodium hydroxide gets added in excess. And as far as the test for cations is concerned, this metal has an orange brown appearance as far as its flame is concerned. And if I have something like lead, of course this is actually an example of a very important metal that can react with oxygen to give what you call the lead 2 oxide. And again, lead 4 oxide, these oxides are actually amphoteric oxides. They have the ability to react with both acids and bases. And apart from lead, you again have what you call aluminium 3 oxide or alumina, and as well zinc 2 oxide. Those three, lead 2 oxide, aluminium 3 oxide or alumina, and zinc 2 oxide, are all amphoteric oxides. They have both acidic and basic properties. So the lead 2 can be able to actually burn with a blue or white flame. Blue or white flame. If I may talk about tin, of course the chemical formula of tin is SN. This one can actually be able to burn with a blue as well or white flame, as the way lead behaves. So they have a similarity in terms of the flames that can be able to get produced just in case those metals get burned in a non-luminous flame when using a nichrome wire. So that is just a summary of what you expect to get. And of course, if I pick carbon, which is not actually a metal, and in this case, if I look at carbon, I can be able to actually note that carbon is actually one of the most reactive elements, because one, if I look at what we call the reactivity series, I always tell students that we have what we call potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron as you proceed. So you have potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, and iron. So that means carbon is just around here. It is actually one of the most reactive elements. If carbon burns in air, it may either burn in excess air or in limited supply of air. If it burns in excess air, it burns with an orange flame or a bright orange flame. Good. Now the burning of carbon in air can either produce carbon 2 oxide or carbon monoxide, or carbon 4 oxide or carbon dioxide. Good. There may be another element like strontium. Strontium is actually a group 2 element. And in this case, strontium has the ability to burn with a red flame. Or sometimes we actually end up seeing what you call the yellowish. So a red or a yellowish flame. So a red or yellowish flame can get recorded just in case this element gets considered. I may have something like lithium. Of course, this is actually a group 1 element, and in this case it actually burns with a crimson red. So you'll find people using what you call brick red, crimson red, or scarlet red. So don't worry about these terms. The most important aspect of this is actually giving the right color. It is red. That is the most important part. So these are some of the color that you can record in, just in case you have what you call a flame test. And it is good that you always give a single color just in case you have an aspect that I've discussed here having 2 colors. For example, if they say calcium is orange red, you just say calcium burns with a red flame, full stop. See? Or calcium gives a red coloration in the flame, in the non-luminous flame. I'm going to show you some of these flames so that you can be able to know going to say this is red and this is yellow and this is white and this is black. So looking at just some of these flames, you can be able to know what you're supposed to actually land on in an examination, just in case you get these questions. So just a minute, I look for the flames that I can be able to show you, and you can be able to know what you're supposed to pick in case you get such a question. So let's just look at this. It's an example of what I've actually sampled as far as those flames are concerned, and I want you to be very keen looking at those flames so that you can be able to know. In this case, so I'm going to enlarge it a bit so that you can be able to see very well. Yes, just a minute. When I want to do the editing, I don't know if it's going to be clear. Let me try. My goodness, it has destroyed everything. Yeah, let me just use this because of time. And if you look at these flames, this is the lithium. After it is what we call the crimson red. Let me see. Okay. I don't know if it's going to work. Just a minute. So we have the lithium, which is actually crimson red. You can have a look at this. The chemical formula of lithium is capital L small I. Sodium is actually orange red. You can just say yellow. If you come here, you have potassium, which is lilac or purple. We have rubidium, capital R small b, which is red, violet, or just violet. The red may not be so clear from this case, so you can just say violet. We have coloration, capital C small s, with a blue or violet appearance. Calcium as what we call the orange red or brick red. We have the strontium that has the red or yellowish appearance. We have the barium that has a green appearance. I'll clearly be able to show you a better image of barium so that you can be able to see. We have copper that burns with a blue-green or a green flame. Now, if you may just want to show you something else that has a different appearance. This is magnesium. This is my magnesium. It burns with a bright blinding flame or a bright glaring flame. And you can see how it is actually bright and glaring or bright and blinding. Great. So something else. Let me have a look at this. I've already looked at this. Let me look at this. This is the flame of barium. I've told it's actually green. 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 Good. Green. You can see where the nickel wire has been positioned in the pale blue region, which is the hottest part of an unluminous flame. And let me see something else. This is the iron 3. You can look at that. I've told you iron 3 is orange brown. So it is very clear that some of these flames should be able to know how they appear. Good. Very good. Let me see something else. Look at the carbon flame. I've told you carbon flame is actually bright orange carbon flame, the bright orange flame carbon.